Look across the horizon of any rapidly industrializing nation today, and you will see raw, physical momentum pushing outward. By 2026, the demand for physical space is set to surge, driven by the nationwide expansion of e-commerce supply chains, logistics hubs, and smart city infrastructure. But this momentum frequently collides with a severe physical bottleneck. Traditional reinforced concrete construction is inherently sequential, relying on slow, manual site excavation and lengthy curing times. In modern corporate logistics, every week spent waiting for a site to finish incurs a direct financial penalty. Profitability is increasingly determined by a strict metric, time to operation. To maintain its target economic velocity, India cannot rely on a construction method that restricts building speed and generates massive on-site material waste. The solution involves shifting the actual construction process away from the building site and into a factory. This is the premise of pre-engineered buildings, or PEBs. Rather than pouring foundations and laying bricks over several months, the physical site transforms into a rapid staging ground where a skeletal steel framework is cleanly bolted together. Adopting this method takes the unpredictable variables of outdoor contracting and replaces them with the controlled repetition of industrial manufacturing. A PEB system distributes weight through a specific hierarchy. Primary steel frames bear the main load, supported by secondary Z and C purlins, wrapped in standardized cladding. Every component is custom engineered for specific load capacities, stress tolerances, and spatial requirements before breaking ground. The physical fabrication happens inside heavily controlled facilities. Here, high-grade 345 newtons per square millimeter steel is cut, welded, and plated to exact mathematical specifications. When those components finally arrive at the plot of land, they are already perfectly sized. There is no on-site cutting, no on-site welding, and zero structural guesswork. Shifting fabrication from outdoor environments to a highly regulated factory floor guarantees exact cost metrics and eliminates common weather and labor delays from the timeline. That level of control directly translates to speed. A PEB system reliably reduces a project's construction timeline by 40 to 60%. Because the steel frames are modular, enormous structural footprints can be enclosed in a fraction of the time it takes to build a conventional facility. These structures also provide vast, column-free clear spans that are highly efficient for unhindered logistics operations while relying entirely on recyclable steel components. This chart shows the global PEB sector's financial trajectory, climbing toward an estimated $97.6 billion by 2036. Within that expansion, India acts as a primary growth engine, tracking an aggressive 6.8% compound annual growth rate. The efficiency of these structures actually begins in the software. The modern design phase is heavily integrated with Building Information Modeling, or BIM. Engineers deploy AI-driven tools to calculate how much steel is required to safely support the structure, running complex wind and seismic stress tests entirely within a virtual environment. This digital-first approach allows for perfect, clash-free coordination of all mechanical, electrical, and plumbing systems long before a single beam is cast in the factory. A completed facility is a highly optimized hardware product, manufactured directly from a flawless digital twin. While single-story warehouses currently dominate the market volume, the application of this technology is rapidly diversifying. The exact same structural principles are now being deployed to erect multi-story commercial buildings, complex solar manufacturing plants, and sprawling public transit hubs. The aviation sector provides a clear example. Aircraft hangars require massive, uninterrupted interior spaces to maneuver jets, a strict structural demand that PEB technology easily accommodates. Complex architectural designs can be translated from digital blueprints into structural reality with exact precision and minimal delay. By eliminating the unpredictability of manual construction, pre-engineered buildings provide the physical platform for modern infrastructure. As India accelerates its industrial output and expands its logistics networks to support a growing economy, it is this highly calibrated factory-built steel that is framing its physical future.